Hi guys, welcome to the next lesson on polarity. In this lesson, we're going to be covering explanation of molecular substances and we'll preface the understanding of low melting point and boiling point in terms of intermolecular forces by looking at polarity. So, the shape of molecules and the atoms in those molecules, they determine the polarity of that substance. So whether a substance is polar or non-polar. So if something is polar, it means it has different ends or different charges on different ends. So we have one end is positive here of the molecule and the other end of the molecule is negative. So that refers to or describes a polar substance. Whereas if you have a non-polar substance, that means you're going to have the same types of charges on either end of the molecule, where it's a positive and positive charge or a negative and negative charge. So here's one end of the molecule and here's the other end of the molecule on this side. Now that you have an understanding of what polar or non-polar is, we can apply this to molecules that we see in everyday life. So, for example, the hydrogen fluoride atom. The hydrogen atom has an electronegativity based on page 162 in your textbook of 2.2. Electronegativity is 2.2, whereas the electronegativity of fluorine is much higher at 3.98. So the fluorine atom is going to want to gain electrons, or it's going to pull electrons more strongly towards itself compared to what hydrogen will. So that means more of the electrons are going to be associated with the fluorine atom compared to the hydrogen atom. So this here is called a delta symbol, and it's delta negative. That means the electrons are more often associated with or found towards the fluorine atom. Of course, there is not a complete dissociation, or not all of the electrons are not found here. They are moving around in the orbits between the two atoms, but they will more often be found at fluorine. If you look at another molecule that is now non-polar, the previous one was polar because we had differences in poles and charges. Look at this atom here. We have an oxygen atom, another oxygen atom, and a carbon atom. So we have a carbon dioxide or CO2 molecule. We can see that oxygen's electronegativity is higher on either end compared to carbon. So electrons are going to be moving towards oxygen with an equal distribution as they are delta negative or have a higher electronegativity. From here we can see that the charges on either end are going to be negative and negative, or slightly negative, delta negative, delta negative. That means we're going to have a polar substance or a non-polar molecule. A non-polar molecule, because they're equal in the charges. If you look at this in a diagram sense from the textbook, so electronegativity describes the ability to attract electrons. If the fluorine atom has a higher electronegativity than hydrogen, therefore it's going to attract electrons more readily, therefore the shape of the molecule is going to become a polar substance. Whereas if you have equal electronegativities, therefore the electrons are going to be shared equally, so you're going to have a non-polar substance. This is shown here as well, where you have the same atom bonding to each other, so F2 or Cl2, they'll have pure non-polar. Polar covalent will be something with different electronegativities bonding, and the extreme of that is the ionic bond, where you have complete transfer of electrons. So it's important to note that a covalent bond, the electrons are shared between both, they're not dissociating or they're not moving away. Hydrogen atom over here or over here will still have electrons around its nucleus, they just will not be as densely populated around there as they will over in the fluorine atom or fluorine nucleus. So when two atoms bond covalently, as I've already mentioned, if they're shared equally, it's a non-polar bond. If they're shared unequally, it's a polar bond. And that's shown again here. Unequal sharing of electrons towards the polar covalent, equal sharing of electrons, non-polar covalent. This table just shows the electronegativity difference between atoms, and you can see that the greater electronegativity, the greater the polarity will be, or the more polar the bond will be. If we apply this to an understanding of molecules and how they look, we can look at a few different ones here. We've already seen carbon dioxide. That's going to be non-polar because of the equal charges on either end, with a negative charge and negative charge. If we look at something like tetrafluoromethane, you've got negative charges on either end. So again, it's going to be symmetrical in shape and non-polar. Something like water, you have a positive end over here and you have a negative end over here with oxygen. Again, oxygen is more electronegative, therefore it's asymmetrical, therefore it's a polar shape. Same thing goes for ammonia here, it's polar, as well as methanol, again, it's polar. This picture here just shows the distribution or the movement of electrons from hydrogen more often than not, they're going to be at the carbon atom and then also at the chlorine atom here. So the net dipole is from here, delta positive to delta negative. This is a summary of today. Polar molecules are when two or more atoms of varying electronegativity are bonded together at each end of the molecule, creating a positive and negative charge. Non-polar is obviously when you have equal distribution of charges, so you can have positive and positive or negative and negative on either end, giving it a non-polar substance. And electronegativity determines that shape. This is a success criteria. You should be able to differentiate and explain what polar and non-polar molecules are and explain why they are. These are the questions to complete, 1 to 5 of page 166, chapter review 7.2. Thanks for watching.